we've got a another really simple scene here. We've got a window frame that you can't select because it's set up in this static display layer. But if you select in that outliner, you could do it. So we've got a frame, we've got a window shade, we've got a string and a handle. And all we're going to worry about is the shade and the handle. So the goal of this is to connect. The driven keys are all about connecting attributes together so that when you change one thing, other things change. And that can make it really easy and efficient to create animation, because in some instances you have one thing changing and that is going to cause 5 or 6 other things to change. So in this case, we'll just talk about one thing changing together and those connections being linked together. So what we want is, we've got this little handle here, and if we move it up and down, nothing happens except that the string lengthens, but that's already set up. What we want is, we want the handle to pull. As we pull the handle down, we want the shade to roll up or squish up. In this case, we're just going to do a simple scale. So in this case, we've got the pivot point for the shade up here, and we just want it to scale up like that. So what we want to do is, we want to connect the translate of this object to the scale of this object. Well, this is pretty simple to do with set driven keys or driven keys. So I'll just reset the translate to y, or translate y to 0. And we're going to go to animate, set driven key, and set. And that's going to pop up this little window called set driven key. And there are two components to a driven key. There's the driver and there's the driven. Now the driver is what you are changing in order to make something happen. So in other words, I wanted to change the y value of this handle, and then I want something to be driven by that. So in this case, the scale of the shade is the driven, and the translate of the handle is the driver. So I'll click on the driver and I'll hit load driver, and that loads the handle in here. And because we know that the translate y is going to be the attribute that we want to be creating the effect, we can select that. Now by default the handle came in as the driven, but what we want is the shade to be driven. So we can click on the shade and we can click load driven, and now we see that we've got the shade here. And we also know that we want the scale y to be what's affected, and so we can select those. Any attributes or channels that you select here will have the keys applied to them. So I could have the translate y driving all of these, but really I just want scale y. So this is just kind of a one-to-one connection. One attribute driving another attribute. Okay. So at this point, now we're going to set keys for how we want the motion to take place. So we want to set the extreme limits of the extreme limits of our setup. So in this case, when the shade is fully down, we want the handle to be about here somewhere. And I think I had already frozen the transformations at 0 at that point. So let's just say at this point we have the shade fully down and the handle is here. So all we need to do is make sure that we've got the scale and the translate selected and hit key. And if we get a result 1 down here, that means that result yes, something has happened. Now we want to set the other extreme. And I should mention that this isn't about the timeline. We're not setting keys in the timeline. This is just a connection between behaviors. So next what we want to do is we want to select we can select the handle, and let's move it to the other extreme. So the handle's pulled all the way down, somewhere around there. And at the same time, we want the shade to be brought all the way up. We can put it up to that, something like that. If we look in the channel box, we can see that there's a key already set on the scale y, and that's because we've set that with the set driven key. So we've got the handle, and if we click on this, it'll select the handle for us. So we've got the handle translate y, and we've got the shade scale y. Those attributes are both set, and all we need to do is hit key again, result 1, and now we've got the connections made. And now all we need to do, now we've got the translate y driving the scale of the shade. If we go beyond the bounds of what we said initially, the shade doesn't do anything special because it's only within the extremes, the keys that we've set, will this behavior happen. Okay, so that's a pretty simple example for how you can use one attribute to drive another. This relationship has a, set that back to 0. This relationship has a graph editor graph associated with it. And I believe it's if we select the shade, because that's the driven, the scale y has something driving it. And so you might notice that there's a new text piece of text here. This means that the x-axis is no longer time. The x-axis is not time anymore. The x-axis is represented by handle.translateY. So for a value of 0, the handle translate y has a value of 0. That means that the scale has a value of 1. When the translate y has a value of negative 1.413, which is the lowest that we put it to, the scale y has a value of 0.0485 because that's what we scaled it up to. So we could change that. We could say, well, actually, I only want the come on. Is it snapping? Oh, I see. It's snapping to the integers. That's okay. We could manually put in a value here. So for a handle translate of 1 minus 1.5, maybe we want that same value, and that means that in our scene we would have to pull the handle a little bit further, all the way to 1.5, in order to get to the top of our shade. Or we could also change things like the tangents. So right now you can see that by default there's an ease in and an ease out. But maybe I don't really want an ease in and ease out. I just want a linear relationship between the two. Because as soon as I start moving this up, I kind of want them to move in a linear fashion to each other. Whereas before, if I set the ease in and ease out, you can see that at the beginning there's not very much shade movement and they look kind of dissociated from each other. And at the end it kind of slows down. So for this kind of direct relationship, you'd probably want linear tangents. It also means that you could add a key. So there's the insert key tool, which I'm just going to add here. We can make something really crazy and just add. So you can see when it goes down, then it's like creating this weird extra jiggle to it because we've added complexity to the animation curve. We don't want to do that in this case, but basically all I'm saying is that the curve is there in the graph editor and it's fully editable for you to play with. But at the basic level, that's a simple relationship, and that's how set-driven keys work. So let's look at something a little bit more complicated. I'll save this as end. Let's create a new scene together. And what we're going to do is we're going to create a cube. And I'm going to do a couple of things. I'm going to move this up 0.5 so that it's sitting on the grid. And if I hold down D and V, then I can snap the pivot point to the bottom. So again, I don't know if that's a familiar hotkey, but if you hold down D, basically you can enter pivot edit mode, and you can move around the pivot, and then if you release D, then it's back to normal. And holding down the V is snap to vertex, so I'm just snapping the Y down to the vertex, so I've got the pivot point set at the bottom. The other thing I'm going to do is I'm just going to select all the edges, and I'm going to go edit mesh, bevel, and I'm going to edit the bevel to have 2 segments, and 0.1 in the fraction, so that's just a little bit of a nicer smooth box. I'm going to soften the edge, but that's not really necessary. Actually, no, I'm not going to do that. Okay, the other thing that we can do with set-driven keys is create some really nice sort of animation helpers, sort of rigging helpers, in the form of new custom attributes. So if we jump over into the attribute editor, we can create a custom attribute that will drive other things, and it could be really anything. In this case, let's drive the color of the cube. So what we're going to do is we're going to assign a new material, a Lambert or whatever, and this is the cube material, and we're going to give this cube just a default color, green, whatever, doesn't matter. Now, wouldn't it be cool if we had an attribute that allowed us to change the color of the cube? So let's do that. We can go into the attribute editor, and if we select the transform, the P cube, we can go to attributes, add attribute. And what I'm going to do is I'm going to give it a name. I'm going to call this color. And for the data type, what I'm going to choose is enum. And an enum is basically a drop-down list. It's a series of values like green and blue. I don't know why they give you green and blue by default, but that actually works for us. So let's use green and blue and purple. Okay, so I've got 3 options, green, blue, and purple. And I'll hit OK. And now if we jump back into the layer channel box, we can see that we've got this new attribute, green, and we can choose from green, blue, and purple. But obviously those things don't do anything because we haven't connected them to anything. So let's go to animate, set driven key, set. And again, we're going to load this cube as the driver, and we're going to set the color to be the driver because that's the attribute that's controlling what's going to happen. And what's the driven? Well, we need to go into the attribute editor, find our cube material, and in this case I'm going to hit, so when a tab is selected in the attribute editor, that doesn't mean that that node itself is selected. We can see the cube is still selected, but in this case we want to actually select the material itself. So at the bottom of the attribute editor there's a button called select, and that means that we've actually selected the material itself and the cube is no longer highlighted. So we're going to load the cube material as the driven. And now we can see, look at all these attributes that we have control over. In this case, we're just going to control the color R, G, and B. Okay? So we have the color as the controller and the color RGB as the driven. Now, by default, with our cube, we've got green set. So that's actually, we're all good to go. So let's key the first one. And now we've got the color green driving this specific set of RGB values. So now let's change the color to blue. And then we can go find the cube material and let's pick a nice blue color, whatever you like. And we'll key that. And then we can go back to the cube and choose purple. And let's go back to our material and choose purple. And it's always important that you hit key because otherwise nothing will happen. So we've got key, all of those 3 things keyed. So now, look what happens if we change the attribute or this in the channel box here. Now we've got our specific settings stored as a quick little drop down, and we don't have to go into this attribute and try to remember what the values were. I guess they're here, but you know, that's a little example of how those sort of things could be handy. So let's add another attribute to our cube. Right? Is everybody okay so far? We're all on the same page? Okay. So let's add another attribute, and we're going to call this squish. And in this case, we're going to have a squish value that's going to go from between 0 to 1. So in this case, we've got float, which means it's a decimal value, and it can range from, well, it could be any decimal value, but here we're going to set a minimum of 0 and a maximum of 1. And the default can be 0. That's fine. All right, so now again in the channel box, in addition to our color, we've got our squish value. And we can set our squish value from anything from 0 to 1. That could be 0.3, whatever. So what are we going to use to have our squish state be driven? And that's going to be the scale. So let's load the cube as the driven. We've still got the p cube as the driver, and now the squish attribute shows up. So we've got squish, and we've got scale x, y, and z. And with the squish value of 0, we've got our scale set to 1, so that's all good. We'll hit key. And then all we need to do is set our squish value to 1. And then let's squish our cube down to, let's say, 0.3. With these extreme values, you kind of want to imagine what's the maximum effect that an animator would want. Would the animator want to squish something all the way down here? Maybe. So let's do 0.15. That's really low down. Now again, we've got the same problem. We haven't maintained our volume. So we need to change the scale x and the scale z to correspond. Now I did a little bit of maths over the weekend, and there's actually a relationship between the scale x and the scale y and the scale z that will allow us to maintain the volume of a cube. By default, when the scale x, y, and z were all 1, what's the volume of our cube? Quick quiz. 1. Okay, 1 unit cubed, right? So if we have our scale y set to 0.15, what's the scale x and the z going to be? And the answer is the square root of 1 over 0.15, because it's the 0.15 times the scale x times the scale z is going to give us the volume. So do we have a little calculator here? We do have a calculator. I don't know if that's going to actually give us the square root. If you want to do animation and Maya and stuff like that, math is just kind of unavoidable. It just is. So we've got, what's the square root of 6.6667? Okay, 2.58. All right. Thank you, Google. So 2.58, 2.58. All right, now let's key that. And now, if we go back to our cube, we've got our squish. And we've got just a single attribute that drives that. And that's much easier to animate than trying to figure out specific values for your scale x, y, and z. So we've got our color, and we've got our squish. And that is basically how you can use set-driven keys to key different things. I'm going to do one last thing because I want to show you a few different data types. Actually, you know, I was thinking about this a little more because I can't help overthinking things. The relationship between, let's go back to our graph editor. The relationship between these is not accurate. At this point it's accurate, and at this point it's accurate, but in between it's not accurate. If we set them to linear, it still wouldn't be accurate. It might be a little bit more accurate, but the volume, even though the volume is maintained at the beginning and the end, the volume is not maintained in between. And that's because the relationship, as I said before, is the inverse of the square root, or the inverse of the squared value of the thing. So if you really wanted to get technical, you could get this graph and you could do, I'm not going to do it, but you could try to generate the correct mathematical relationship. But I digress. Math is fun though. So we're going to add a Boolean attribute. And a Boolean attribute is either on or off. It's yes or no, true or false, 0 or 1. It's, why doesn't it like that? Oh yeah, we need to specify an attribute name. Of course. We're going to call this bevel. So the bevel attribute, if it's on, we want to set this to have the nice bevel. And when it's off, we'll just have a regular cube. So when the bevel's on, what do we want to be the driven? Well, we actually want this polybevel 1 node. So we'll come over here to polybevel 1. We'll hit select. And we're going to hit load driven. And now we've got the polybevel exposed to us that we can make the changes that we want. So with the P cube, we've got the bevel selected. And we've got the fraction selected. Actually, is that what we want? Yeah, I think we want the fraction. Okay, so I'm going to hit key. And then let's turn the bevel off. And let's go to the polybevel. And let's turn the fraction down to 0. And that means that we just have 0 bevel. So we'll come back to the polybevel and hit key. So now there's no sort of intermediate. It's just either you've got a bevel or you don't have a bevel. And so you could see how you might want to use that if you have like a proxy for a character to keep your scene sort of low poly and smooth and quick when you're working on your animation. And then when you're rendering, you can have your high quality something. I'm not saying that bevel is necessarily the best way to do that, but you can see how you can set up these little attributes to drive other things in your scene that make animation a lot faster and more efficient.